Okay, so now that we've been exposed to the Proteus motion training tool, how does this relate back to simulation? Well, we heard that FEA capabilities, for example, were something of value to this company. And I think that that company, as well as your companies, would like to know, well, what value enhancements have been made inside SOLIDWORKS in this new release, and particularly in our simulation tool sets. Well, how about over 200 enhancements and performance upgrades throughout the year? And we're going to pick on some ones that are extremely salient for us simulation users. For plastics, for flow, and our value offers on the 3D Experience platform. You heard in the video Paul talk about the 3D Experience platform. We'll take a look at that briefly as well. So getting right into it, let's take a look a little bit more in detail at the Proteus Motion Training Tool, a training tool built to perform for professional athletes, which is why you'll probably not get one in my own gym because I'm not a professional athlete. And yet that range of motion, the hardware, the connectivity, just the type of workout you can get from it is it's really intriguing, isn't it? Well, these are the categories in the structural analysis tool set, SOLIDWORKS Simulation, that we're going to take a look at. Okay, so SOLIDWORKS Ultimate, you may have heard about this. This is a sort of a new branding of SOLIDWORKS. It involves and entails the use of our simulation tool sets. And we're going to focus our attention on the use of SOLIDWORKS Simulation with this handle. The handle is how the athlete connects to the machine, and ensuring the athlete's safety while using the Proteus Motion tool is extremely important. Now, the handle needs to be both strong enough to endure the forces of a Major League Baseball swing, but yet lightweight enough to simulate the feel of the bat in the batter's hands. It's a highly designed assembly that'll need to be virtually tested to meet all of the design criteria that the team has. Now, the new features in SOLIDWORKS 2025 are used to speed up the analysis of this handle. And first, there's exclude others from analysis. This is a sort of little hidden gem, a little benign feature, but you know what? It's super powerful. There's several components that need to be analyzed in just this handle alone to make it function properly, yet many of those components are not integral into the handle's structure at all. So new in 2025, we can select now just the structural components that we want to keep and exclude all of the others. It's a huge time saver, especially if we were talking about large assemblies. Now, you'll notice that there's no physical hardware present in this model. That's a simplification process that we often do, and we use it with connectors. Now, notice that the new pin connector has distributed coupling as part of the formulation. This is a more accurate means of providing the necessary forces through those pins, but to keep the parts together inside this assembly. So virtual pins can use distributed coupling. Distributed coupling is not a new technology, but we've migrated it now into the use of the pins. Okay. And along that vein, how about springs? We have a new connector called General Spring. The handle is connected to the rest of the machine, but if we added a rigid boundary condition, it would over-constrain the model. So in reality, there's some sort of compliance to the rest of the machine. And so new in 2025 simulation, an orthotropic spring type can be defined with unique stiffness values in all three orthogonal directions, plus torsional and bending stiffness as well. Now, if you've used any type of spring connectors before, you know that previous to 2025, a little bit of limitation on how you can define those spring connectors. Sometimes we'd have to put in some dummy bodies to add some additional springs. I think this new spring connector is really potent in that we can eliminate quite a bit of the bulk stiffness of the rest of the assembly and just focus in on the problem at hand. I really, really like that. Now, if we take a look here at how many parts are being reused, we need to mesh this. And the new thing, and this is really, really cool in 2025, is that assemblies that contain identical parts will now mesh up to 15% faster when using the blended curvature-based mesher. So what does this actually mean? It means that if I have repetitive patterns of parts, or if I'm just using the same part over and over again, it doesn't even have to be in a pattern. the mesher, the curvature-based mesher, is intelligent. It knows that it's done this part before, it's meshed this part before, it reuses the same mesh, and that's going to save us a lot of time. 15% on a really large assembly with a really complex, dense mesh, 15% is nothing to scoff at, for sure. Okay. Now, there's some other things in here that I'm not going to show, but I'll just point out. Node to surface bonding with offset. The illustration here on the right is an I-beam with solid elements and then a bracket made from shell elements. And sometimes we want to enforce a gap between, say, the sheet metal bracket and the rest of the structure. Well, now there's improved accuracy when we use the node to surface bonding option when we define contact between those bodies. So again, we're not going to sacrifice accuracy, we're improving accuracy. And then similarly in surface to surface bonding for contact that involves cylindrical, conical, or spherical surfaces, we've improved accuracy there as well. Now, this doesn't mean that you have to mesh this super more densely than you would before. The formulations that we use, the forces we extrapolate, the math behind things have improved. That's phenomenal. Okay. Now, some components in the Proteus motion machine are injection molded plastic, and we want to make sure that they look aesthetically pleasing and also meet the form, fit, and function requirements. So we have some improvements on the solver side for both warpage results and sink mark prediction. Let me go ahead and show you that. So here's one of the parts in question. Plastics 2025 can help us in designing the perfect part right from the get-go. The new results break down overall warpage displacements into unbalanced cooling, orientation, and non-uniform shrinkage to give us better insights. Now, injection molding is a process, and SOLIDWORKS Plastics speaks to that process really well. The better insight we get sooner, the more time and money we're going to save, especially when we talk about the cost of hard tooling. So being able to accurately predict warpage, shrink, and other process failures early on, well, that's extraordinarily beneficial. And I say that as someone who's designed quite a few plastic injection molded parts. Okay. If you're not familiar with SOLIDWORKS Plastics, it is actually a type of CFD software, but it's not the same thing as SOLIDWORKS Flow Simulation. This speaks particularly to plastic injection molding, a little bit to metal injection molding, if I had to be honest. There's some capabilities in there as well. But it's a great early insight tool, as all our simulation products are, including SOLIDWORKS Flow Simulation. So what's new in this guy? Well, it's a little bit more behind the scenes, large assembly pre-processing and fast mesh generation for convergent geometry. What does that mean? It just means that we're trying to make the users, you and me, our lives a little bit more simple, being able to tackle a little bit larger problems, especially when we talk about larger assemblies. Oftentimes, we have companies that, like some of yourselves, that want to understand the bigger picture, and they want to use a robust tool to do that. SOLIDWORKS Flow Simulation probably is one of my favoriteest sim tools that we offer. It's so easy to use, but you know what? If someone wanted to lay out a plant and study the HVAC system in totality, that's a really big ask of any general purpose CFD tool. Well, some of the enhancements in 2025 can help speed up basic operations like opening these large assemblies, creating, cloning, copying studies, copying boundary conditions, and speeding up some meshing, especially if we're talking about imported geometry. Convergent faceted or stereolith files are triangulated. They don't come in nice and smooth and clean. And if they do, they're really, really small triangles. And the mesher needs to deal with that. So they've improved the handling of that type of geometry in SOLIDWORKS Flow Simulation 2025. So there we have it. SOLIDWORKS Simulation for FEA, SOLIDWORKS Plastics, and SOLIDWORKS Flow Simulation. That's a good handful of things that we've seen here in 2025 that speak to usability, performance increases, enhancing the product so that we can focus on our designs and not necessarily get so hung up on how to use the right tools. Sometimes, however, SOLIDWORKS Simulation, SOLIDWORKS Flow Simulation even SOLIDWORKS Plastics, while it's the right tool, we have an application where the geometry just requires a little bit more horsepower. And I'm talking about what we call our value offers. This is our 3D Experience platform. This is the power of our larger brand of simulation tools that we call Simulia. SOLIDWORKS Simulation is actually part of Simulia. A lot of people don't know that or acknowledge it, but SOLIDWORKS Simulation are our in-CAD tools, and Simulia as a brand is a plethora of different physics-based solvers for a variety of problems that we may throw at it. I'm going to talk about the roles for simulation designer, simulation engineer, simulation analyst, and simulation multiphysics. That's how we break out the simulation capabilities on the 3D Experience platform. Now, this particular role, simulation designer, you can kind of think of it as halfway between SOLIDWORKS simulation, simulation professional, with a little bit of functionality that you might find in Sim Premium. In other words, it's an extremely valuable offer for us performing finite element analysis. The key capabilities of this tool set is linear static analysis and linear dynamic analysis. But of course, we're still working seamlessly with our native CAD. We never really leave SOLIDWORKS. That's the value. That's the beauty of the 3D Experience platform, is it's collaborative. Some of the tools are cloud-based, but I'm never leaving SOLIDWORKS. I'm always in SOLIDWORKS or using my SOLIDWORKS data. There's a comprehensive material library, just like we have in SOLIDWORKS Simulation, and powerful results visualization, also like we have in SOLIDWORKS Simulation, but yet shareable, communicable to a wider audience because of the platform. Okay, so if we take a look at the user interface, it starts here inside SOLIDWORKS. I have access to my various roles. You can see those roles on the left. And when I'm in the platform, it doesn't really look that different, does it, from SOLIDWORKS? In fact, I've got this guided assistant that helps me set up my problems, assigning my materials, my boundary conditions. I'm working natively with my SOLIDWORKS data, and yet I can leverage the cloud if I have a large enough problem. If I have the resources available, why not use them? In fact, I get 8 cores out of the box for free, either local cores or cores on the cloud. And that post-processing, making these images and sharing it with my colleagues like I'm doing here, are made so much more easier because my results can stay on the cloud or they can stay on my local machine. And I even have a hybrid mode where some of it's on the cloud and some of it's local. I've used this tool now for a year, putting it through its paces. And I've got to say, using the cloud compute is extraordinarily easy. I can right-size the job pretty quickly, but then I can also check when those jobs are running from my phone. I can't say I've done it while I was driving, but I certainly have done it as soon as I get home. I whip out my phone and load up the page, and I can see whether the job is still running or if it still needs some time to solve. The next level up, simulation engineer, encompasses the roles of structural performance engineer, simulator collaborator, extended storage, learner's role. These are all different apps that feed into how we use and learn how to use our tools. It's still accessible inside SOLIDWORKS. All of our tools start off by being inside SOLIDWORKS, but here I'm looking at nonlinear behavior, sort of like Sim Premium, custom nonlinear materials, amazing mesh element libraries, and really, really powerful contact solvers. Why? Well, because if you've heard of Abacus, this is the Abacus technology under here. Powerful solvers, powerful meshers, but the ease of use, the ease of learning it, like SOLIDWORKS. So I quickly make my design changes in SOLIDWORKS. I refresh my data on the cloud, remesh, resolve, and I can then compare my results just like I would inside SOLIDWORKS Simulation. Side-by-side comparison, an amazingly powerful tool. Almost as amazing as what we get in Simulation Analyst. Now, this is durability and mechanics. Durability speaks to fatigue. Simulation Collaborator, which is another level of collaboration on the platform. But the key capability is the one that I think, oh boy, blows my mind every time I use it, is explicit dynamics. Here is an illustration of explicit dynamics. That's pretty explicit, and that's pretty dynamic. Yeah, drop test, crash test, things that have fracture, things that have plastic failure, that's all part of the capabilities of Simulation Analyst. This goes above and beyond SOLIDWORKS Simulation Premium. In fact, I can think of numerous applications in my own career where Sim Premium could only get me so far, especially with hyperelastic materials and lots of plastic deformation in plastic parts, where this tool set is really best suited for. We can see that side by side. It's just absolutely amazing. And I've seen a number of drop tests. I've seen a number of fracture analyses done. This is really quite the cat's meow. And again, all on the platform means that I can easily collaborate and share these results with key stakeholders in the business. And then to round things off, I talked about the durability, and that's fatigue. Now, you're probably familiar with SOLIDWORKS Simulation's fatigue capabilities. They're really powerful for high cycle fatigue on ductile materials. It's a great tool, but what about low cycle fatigue? What about materials that don't have a nice predictable mean stress? Well, we need additional tools, don't we? And durability mechanics engineer role provides those with not only stress life, but strain life based for high cycle and low cycle. Advanced fatigue that involves creep, a wide assortment of material models that support things above and beyond ductile materials. And of course, the ease of use, the ability to compare, the ability to share. This is really just a very potent tool set that's predicated on, again, some of the advanced technologies that we find in the Simulia brand. And then last, simulation multiphysics. What do I mean by multiphysics? That's a term that's been bandied around quite a bit. Multiphysics means that we can now share data, not now, we've been actually able to do it for a really long time, but people just don't know it, share data between various disciplines. Here, I'm using our fluid mechanics engineer role to do an external flow analysis around this product, to analyze its design, to compare against another design change by putting a fairing on it, and then the loads that this product experiences, the pressure distribution like we see here, those get automatically mapped over as boundary conditions in any one of the three products that we just saw a few seconds ago. Sim designer, sim engineer, and sim analyst can all take the thermal loads, the pressure loads from the fluid dynamics engineer role and use them to solve the structural calculations. Now, I don't have it keyed up here, but we also have our plastics injection engineer role. Same thing, our thermal residual stresses, those things inside that could possibly warp the part that we predict as warpage can be exported out as boundary conditions into structural analysis. We can really see what my product performance is going to be, both from the injection molding side or here from the fluid mechanics side, as well as the structural mechanics side. So they all work hand in glove. Now, how does this tool differ from SOLIDWORKS Flow Simulation? I would say the key difference between Fluid Dynamics Engineer and SOLIDWORKS Flow Simulation is that on my laptop, I can run SOLIDWORKS Flow Simulation up to maybe about 4 million cells. And then my laptop starts whimpering. There's a little bit of smoke that starts leaking out from the sides. It's a pretty good size problem for SOLIDWORKS Flow Simulation. I don't have those limits with Fluid Dynamics Engineer. With Cloud Compute, I have access to so many different clusters, so many different nodes, terabytes of RAM. I can really solve complex physics problems in the fluid domains, in the fluid thermo domains with Fluid Dynamics Engineer. I've got rotating bodies. I've got, rotating mesh, pardon me. I've got free surface problems. I've got non-Newtonian fluids. I've got comparison tools. I've got parametric design study tools like we're going to talk about next week in our simulation power hour, which I want to do a little plug for. We'll be doing the design of experiments topic as applied to fluid mechanics. Well, we have those capabilities here in this role as well. So there's a really great analog between what we can do in the desktop with SOLIDWORKS simulation, flow simulation, plastics, and what we can do here in our value offers on the platform. I'm really excited about new releases. I love how the developers do listen to us. You know, sometimes we get frustrated, things that we really, really want, we don't get as soon as we want them. We might really need them, but the developers do listen. I had the privilege of being part of a roundtable discussion for all of our products earlier this year in Texas at the 3D Experience World. And I got to tell you, talking to the product managers, talking to some of the developers, commiserating with other resellers, as well as the engineers at Dassault, just a fantastic opportunity to share and to learn and to be your voice, to be your advocate. I know that we all have the ability to launch enhancement requests. We can make SPRs. When bugs are found, the development team assigns priority, and they often work with you guys and work with us to figure out the true scope of things. That's great, but there was something special about sitting down with the product managers themselves and being able to advocate for you guys. It was really a powerful experience. That wraps things up. It was sort of short and sweet, but I hope you found some wonderful nuggets in there. If you have any questions about any of the what's new features that we saw today for structures, for flow, plastics, platform, or any of the ones that you may have seen in the previous podcast, please don't hesitate to reach out to us. We'd love to hear from you. Or maybe you can meet us up at one of the many user groups. Now that we are meeting again in person, we've been doing this now for a couple of years, the user groups are getting a fresh breath of air. I'll be really excited. The user group in my area, there's a new one that's starting up in a couple of weeks. Totally looking forward to going to it and seeing some of you guys in person once again. But that pretty much wraps up episode 5 of our podcast series. I hope you enjoyed it. Coming down the pike, electrical, SOLIDWORKS electrical 2D and 3D. Really excited to learn about what's coming up in 2025 SOLIDWORKS with regards to these products and these capabilities. A long time ago, long time ago, and for a very brief while, I also handled the electrical tools, a little bit out of my wheelhouse, but it was still fun nonetheless. It's been an amazing journey seeing how this product has evolved and how it meets the needs of mechanical engineers and electrical engineers.